answer out of it. So I would say rapid progress in NLP, in machine learning and deep learning. So we was number one in March and August, but like just 2 months later, there's another system from Google, which is BERT, that's outperformed human, and I think this is really amazing. I actually tweeted online that this is a new era of NLP. Everyone should remember this keyword BERT. This talk a lot about being talked a lot in the field, because let me talk about it. So the important thing here is that you don't need complicated model. You only need lots of data, and then you need the power of the computing powers, which is this case Google Cloud TPU. So they was able, this is a picture that a bit technical, but the whole point is, in the past, people try to represent each word by a vector, but that is out of context. So the word Apple can have two different meanings. So whether it's a company, if there's a word like stocks, market, or like iMac, like MacBook appear around it, this is the word Apple would mean the company. Or if there's a word like farmers, then we would guess that this is about the fruit, right? So BERT is trying to build the representations in the context. So now your word vector is more meaningful, and just by training on large amount of data like that, you was able to get a very good representation of the words. And then you can just apply to any downstream task very easily without building complicated architecture. So this is like a really new trend. Like we spent like a whole year building a very complicated models, like many layers stacked together. And then now just like by doing lots of like unsupervised learning, train on massive amount of text, you was able to get good representation of the language. And then you can apply to many downstream tasks, whether it is sentiment analysis, whether it's the question answering, anything, the same kind of pre-training, the same kind of representation you can just apply. So that is quite remarkable. And the very last slide, I think we can also do something for Vietnam. We can also train the kind of like BERT model, the kind of unsupervised learning models for Vietnamese. If we can collect a huge amount of like just text data from newspaper, I saw people start collecting lots of articles here. I think that is quite encouraging. So by just training those, right, a lot of applications can be used. You can learn how to add the little accent, dấu câu, or you can learn to like turn it from lowercase to uppercase, or detect names, or you can even like complete a sentence. So these are the kind of thing that you would want to do for your chatbot. I guess everyone likes chatbot. So to wrap up, I think there has been rapid progress in language technologies, and the mature area, I think you can start using, if you have access to Google Cloud or AWS, you can already use speech recognition, speech synthesis, machine translations. So question answering is actively developing. And the last point is, I think Vietnam needs a large text data set. So thank you.
All right, I'll take over. I guess people are not bored of me yet, so they asked me to come back and become the moderator of next session. So can we get the chairs up? And so the next panel is going to be on real-world application of AI. So there's going to be Phương, Thắng, and then Kenneth, Nguyen. Oh. And then Raf Regalado as well. Raf đâu? Raf đi mất rồi hả? Where's Raf? Raf, Regalado. Oh, okay. So how do you...
Deep learning is this branch of machine learning loosely inspired by how the brain works. We have had experience building software for deep learning over the last few years.
Although it was initially a research project, we've since collaborated with about 50 different teams at Google and deployed these systems in real products across a really wide spectrum of areas. Today, it's used heavily in our speech recognition systems, in the new Google Photos product, Gmail, in search.
We've really taken all that experience and built that into TensorFlow. TensorFlow is this machine learning library that's used across Google for applying deep learning to a lot of different areas.
Doing both artificial intelligence research and deploying these production models. They're really powerful at doing various kinds of perceptual and language understanding tasks. These models are able to actually make it so computers can actually see.
I think this is actually another panel that I'm super excited about. Okay, so I would like to kick off this with maybe we'll do a round of intro with the speakers. So, you know, your name, your company, what is exactly the real world application of AI that you are working on, and what is your biggest achievement with this project? Okay, all right, let's start with Tang first.
So I'm Thang Leung. I work at Google Brand. So in the past, I have built translation models that has been deployed to Google Translate. I think that is the thing that I'm most proud about. And we're currently working on question answering. This way, when you search Google, for example, you don't have to read through all of the documents, the search results. Hopefully, in the future, that can save time.
Hello again, I'm Ken. As I mentioned several times in my presentation, one of the real-world applications that I deeply care about nowadays is sustainable food production in a controlled environment. Ultimately, I would like to have a robust, generalizable framework that can work across industries in agriculture, energy, and transportation, and I would happily retire once I can solve two problems.
My name is Wen, founder and CEO of Dressing Social. We solve only one problem, which pick a random person in the world. We should be able to answer, should a bank lend money to them? At what interest rate, with what expected credit loss, and by what amount. So we'd like to do that for at least 3 billion people in emerging market, and by that I also retire with Khoa.
Hi, I'm Ralph Regalado from the Philippines. I work with Senti. So Senti, it's a localized NLP platform. We do analyze text in the Filipino language. We work well with corporate companies who would like to build their own custom NLP models. So right now, like we're working with insurance companies who would like to automate some of their claims processing. So one of our client, like we help them reduce around 25% savings for their claims processing. And like we also work with airline companies, marketing and advertising agencies who would want to recognize and understand all of their text data.
Thanks, Graf. My name is Phương Hoang. I'm from graphics minor and also from VIETAI. So we are focusing on utilizing simulation and AI for students from primary, secondary, and high school to learn to learn in interactive and intuitive way. So what I'm really proud of is until now there are many people still staying at the dream place to listen to us.
Right. So from your experience, right, what are like the most common pitfalls that any AI practitioners should be aware of, and how to avoid them? So maybe we can start from that your end. Pitfalls, common pitfalls that people should watch out for.
Yeah, the common pitfall, like we think like AI or machine learning like black box, and we just study what many people they mention about the term. We don't understand exactly what is the math mechanism behind it. So if you understand math, you will fall in love with many other things, not about AI, not about ML or DL.
Yeah. I think in our case, it's more of like acceptance of the technology itself, because people tend to, when they talk about AI, it would replace people on their jobs, right? So it's more like first, if relatively you're working with a company, you need to educate them as to what's the impact of it. I think to highlight what Ken mentioned, the economic value always plays a part, especially if you would want to work with corporate companies and would want to understand how AI would be beneficial for them. So very important thing is for you to talk to the right people, especially if you're working with corporate companies who would want to invest artificial intelligence. So talking to the right people, changing their mindset, and make them accept that AI is relatively something that they cannot, that AI would come regardless of they would accept it or not. So it's more of like changing their mindset.
For probably the biggest sin is brute force, because we deal with the data generated by human behavior, and the search domain is ridiculously large, and people don't act the same way that machine acts. They act strategically, and without understanding human at a intuition level, then we'll be solving wrong problem for a very long time.
So in my first tech talk here, I gave a talk about the 10 lessons in machine learning. So basically, I already described the 10 common pitfalls. But on top of my head right now, I would like to say that one common pitfall for AI practitioners is to approach their clients, to approach the end users and saying that we have AI. Instead, they should approach their customers, trying to understand what problems those businesses have, and then claim, hey, we can solve your problem, we can help you save 20% of your cost. And just FYI, our technology is called AI.
So for me, one of the most common pitfall of AI practitioner is you want to apply AI too early. So I think, so for many problems, maybe just a simple solution might work. So you might want to think about simple solution first before thinking about AI problems. So you have to set up a baseline, what is the performance you can get without AI first, and then you start talking about AI. So I think I see that problem a lot. People, oh, I want to use AI, let's do AI. But sometimes you do complicated solution and it doesn't work as well as a simple solution.
So this is very, very interesting. So you guys are talking about the gap of, what people expect AI to be able to do, and treat it kind of black box, and what actually, can be delivered to the consumer or, the customers. So what is the limit of AI, right? What are the kind of like, let's say, the type of signals or problems that you would like caution people here to say, look, you know, let's try to really understand the problem, or let's try to apply some other solution before you go into AI. Any insights from there?
So a real problem that we have is that when we train our model to predict credit risk in Indonesia, we have a beautiful model that basically or increase the risk decrease linearly. Beautiful model, similar to Vietnam. But when we go out and start matching people with the lenders according to that score, suddenly the curve look exponential, right? So what caused that? It's actually not included in the model because the model was trained from existing methods, whereas our product introduced a new kind of bias. So in lending and in human data in general, the strategic aspect of human cannot be modeled in advance just because you never have data. So, but at least knowing that, we can design different experiments so that we kind of don't get surprised, right?
Yeah, very interesting. Kind of know your limit before you actually attempt it, right? Yeah. Any other insights?
In our case, again, the concept of outcomes razor, right, comes into place that you need to start first with the very, very simple model, because sometimes simple model is already enough to solve your solution. And you go there step by step. So once a simple model is not enough, then you can explore a new machine learning model. But it's very good also to recognize what is a standard, what's the baseline currently that's appropriate and available for you now. Because sometimes if you tend to be, sometimes you have clients that they need to have a quick prototype immediately with, they need to see automatically the value of it. So probably you would leverage first existing APIs, but if you would want that specific model to be improved, and then you move it to a much more complex algorithm. So you try to look into first what's available out there that you can easily like build and develop, then you progress and explore new algorithms or much more complex algorithms.
In the past, in the past, people, we came up with a kind of hypothesis-driven approach. I mean, we have a kind of correlation between variables, and we have a kind of the way we can reason, we can predict. But right now with AI, it seems like we got a lot of data, and we put it in a system, and somehow it works. So, I mean, correlation doesn't mean causality. So, if AI system can show us the uncertainty, I mean, like Bayesian approach, it could be great for any reasoning process. Yeah.
Just to clarify, the question is, what is the limit of AI systems?
How do you envision the limits of AI system, or how do you identify the limits before you look into the problem and try to solve it, right? So any insights on setting, okay, so this is not a problem for AI, or this is the right problem for AI. So how can you tell between the two?
Yeah, so I think one advice I often give to people, AI practitioners, is first you have to look at the size of your data. If you only have 1,000 data points, you cannot use AI, or maybe you can still use AI, but I mean, like, there are different techniques. For example, if you talk about deep learning, you might need more data points. Yes. You need like 100,000 data points, or at least like 10,000 data points. So you need to know your data size. I think that's the important question.
Yeah, that's a great point. You want to add anything, Kenneth?
Yes, I think, so this doesn't apply to just AI. Before you use any tools, whether that tool is the right tool or not, you need to understand. So some education is required. Like it's unavoidable. And once you learn, you understand what it's capable of, what's the limit, then I think it wouldn't be natural that you understand whether you should apply it or not. And just to be clear, AI is a very broad term. So AI contains zillions of techniques. So when you set out to solve a problem, you need to be specific about the your problem definition and the tools and the techniques that you already know about.
I just want to add one point. So when people look at problems, right, you should look at a big picture. I think we should look at, there's a supervised learning problems where you have a label, like whether this is a cat or whether this is a dog. So we know that supervised problems are quite, I wouldn't say easy, but we sort of have a success in solving those. So we need to understand that. We have techniques for the, and for problems where we have few data points, then there's a question whether you can transfer, you can do some transfer learning. Maybe you do some unsupervised learning on large amount of like text data, or you teach the machine to just look at image like randomly, like maybe just like any types of image, and then you transfer to certain domain. So I think these are the questions you might need to think about.
Yeah, absolutely. I think you brought up a really interesting point that data is king, right, in the AI or machine learning realm, and it really depends on how much data you have that will dictate kind of like the approach, the solutions. So in your experience, what are the creative ways that people have been using to squeeze more data out of a problem? Would love to hear your thoughts so that, in Vietnam we've been saying like, oh yeah, we don't have data, but how do we generate more data in a very creative way? Any examples, any thoughts?
So standard in machine learning is the data augmentation approach. People always have the need to enrich their data. For example, for speech recognition, you have a data set, and then you start adding all kinds of noise from the kitchen, from the bar, or on the street. By adding all kinds of noise, you have more data. So that's for speech. And then for vision, then you rotate your image. You add background images. You change the lighting, so you get more data.
Great.
Another more scalable way to get a large amount of data is to be able to learn from weak signals, from bandit feedback. So think about running a search engine or a recommender system. So Google users will not label this result is relevant or not. Like, nobody does that. But all Google or Amazon and other systems, what the signals that they get is whether some link or some products is clicked or not. So the click is a weak signal. So we should think about how we can design a system that can learn from large amounts of weak signals rather than only trying to learn from fully labeled examples.
Agree with Hoa that we come from the background that we have a lot of data, but each the signal have very low correlation. Understanding the interaction of these signals in a large quantity actually helps us a lot in building the world-class risk assessment models. One example is that, for example, in India we have a network of 850 million people with billions of connections. That's a lot of dimensions. Each of them is very weak. How do we synthesize those dimensions into smaller number of dimensions that meaningful for the Indian population is a challenging problem. Another issue with credit data is that it's very expensive to run experiments, because let's say we want 1 million loan to train the data, then we're going to spend a few $1 billion just to collect that data. And these data tend to be very biased to certain segments, certain products, certain underwriting policies. And the variation of this is mind-bogglingly big, right? So when we design the model, we have to incorporate the certain kind of data from certain kind of process for certain kind of banks for to create a representative sample of a country, right? So we don't need to go to every bank in the country, but if we can go to, let's say, a lender that cover the biggest spectrum of the country with least bias, and we start from there.
I think same thing, that we don't really have an issue with data. This is very important because when you deal with businesses, they have a lot of data. So it's more of like understanding which in the business process produce the most data and try to leverage on that. So in our case, we don't have any experience yet that we have less data, because most of the data are relatively stored in a huge database of these companies, and it's already labeled. By the way, they manually labeled it. They have their own effort of like categorizing data. It's a matter of like automating this to have a much more efficient process within the business. So our approach really is more on the other side. Like, we tackle the business process first. Like, okay, what's your business process? What are the data around this business process? Is it something that you can apply artificial intelligence into it? How many times do you process this type of data? So if you have seen an opportunity that you can relatively leverage, or they have huge data, and it's relatively, a lot of people are investing a lot of effort in this, into categorizing data. So there's already like one key point: you can now have an economic impact, and you also have a leverage on the internal data itself. So try to look the problem into a different setup, like, because corporate companies have a lot of data. It's a matter of like investigating the business process within the corporate business itself.
Yeah, squeezing data is like, it's very difficult. For my team, 1.5 years ago, we started with several guys, and we think about the way to apply AI for education, and no data. I mean, this is like, there are many data, but kind of messy one to learn to build up kind of virtual assistant. So we think that in the way that we can construct a platform, an educational tool for teachers and students, and somehow they have the moment they love. They can create something. They can generate a lot of text as well as images for us. So all kinds of the educational data set gonna release to many developers around the world. Hopefully next year. I'm not sure, but hopefully, yeah. So from startup point of view, I mean, we try to do our best to serve our customer. But meanwhile, we try to collect the data to, to support them in a better service. And another way to think about the problem, I think maybe like, this is kind of a bottom up, but we can think about a kind of top-down approach. Even Brazil, Chile, and Kenya, and the US, they have their own open data, data initiatives. But what about in Vietnam? What about for Southeast Asia country? What do you think?
Yeah, I mean, that's a great point, right? So I think I mentioned earlier that, that China made so much progress in machine learning recently because they have farms of people just labeling data, like a sweatshop, right, for data generation, which is, it's just mind-boggling.
I was about to add that idea. So I agree, and it is a lucrative business in China. And someone here should try to set up a similar business here in Vietnam. Lower labor cost here in Vietnam, loss of demand, and someone doing it, I would be a happy investor.
Yeah.
So there's also one strategy that some of my Stanford friends had done, is that you crowdsource data in a smart way. So you don't label for every example, you only for difficult example. Then you connect to maybe Amazon Mechanical Turk, or maybe future, labeling farmhouse to label those difficult cases.
And I've seen actually some of the project on blockchain, they tokenize the data and incentivize user by reward them with tokens when they contribute data. And then of course they have like cross checks and all that stuff, which is a very, very interesting approach. But on the other flip side, right, when you have too much data of one type, it usually bring in bias or overfitting. So here's a funny story. Funny in the sense that it hasn't happened yet. So there's a self-driving cars, right? There was some some person on a wheelchair was crossing the crosswalk backward, and